Okay, so today we're going to go through medians and altitudes of triangles. Okay. First, you need the definition for median of a triangle. Okay, median of a triangle. Okay, it's a segment with endpoints being a vertex of a triangle. Okay, so it starts like at the vertex of a triangle. Okay, and then it connects to the midpoint of the opposite side. Is this angle down here a right angle? Do these look at like right angles? No. The median goes from the vertex of a triangle and then take the opposite side, and it actually goes to the midpoint. Okay? It actually goes to the midpoint of the other side. It does not form right triangle or right angles. What's that? I would. Yep.
Can it form right angles?
It might, but most of the time it won't. Yeah. Okay. So draw a triangle. Okay, whatever, you don't have to match my triangle up here. It's just got to be a triangle. And then go from the vertex and estimate on the other side, estimate the midpoint. And then draw a segment in between. Okay, same thing, go from the vertex. On the other side, estimate where you think the midpoint is and draw the segment. And that segment is called, this segment is called a median. This one is also a median. BE would be a median. Okay, FC would be a median. Okay? And that's what I've written out at the side. Okay? So, if you're drawing it to the midpoint of the other side, then that means this part's important. These two segments are congruent to each other. Like EC is congruent to AE. Okay, so mark them that way on your triangle. And then like AF is congruent to BF, mark it that way. Okay, so the segment going all the way across from the vertex to the midpoint, BE is a median, AD is a median, and CF is a median. Okay, now that gives us another center. Okay, there's like 4 centers of the triangles. We've done end center and we did circumcenter in 5-1. Now this gives us the third one, and that's called the centroid. Okay, the centroid is the point of concurrency, okay, of all the medians. So G is the centroid, okay, for this triangle. Okay. So we've done intersection of perpendicular bisectors, we've done intersection of angle bisectors, now we've done intersection of medians. Okay? Is that pretty good? The centroid is the point of concurrency of all the medians. So G on this picture is the centroid. Okay. Okay. Then they give you the centroid theorem. There's on the centroid there's a special relationship. Okay, and that's theorem 5-7. It's called the centroid theorem. Okay. The medians of a triangle intersect at the point called the centroid. The medians of a triangle intersect at a point called the centroid. that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay. Now, I want you to look at this picture for a minute. Okay?
Looks like a circumcenter and it's usually about the same thing.
The circumcenter is the intersection of the perpendicular bisectors. This one we don't have right angles here.
Alright, so it's
Like if it was a perpendicular bisector, it would be coming about right through here. Okay? Straight up and down and be perpendicular. Okay?
so this doesn't have to be a bisector. That's why it's called centroid.
No, now wait a minute. Medians, go back up. The median does bisect the other side.
No, it's the midpoint. Or yeah.
It still bisects the other side. Okay? But there's no right angle. The perpendicular bisectors, it would still be point D here, but the perpendicular bisector would have gone through about like that. Okay? So that's going to throw you a point. Yeah, they're not the same. Okay? Good question. Okay, I do want you to look at the relationship between these. Okay? Okay, everybody look for a minute, even if you're still writing. Look up here for a minute. Look at this whole thing. Okay? There's a special relationship on centroids. Okay, if you look at this whole median, okay, AG, this segment AG is 2/3 of the whole thing. Okay, AD. So AG is 2/3 of the whole thing, AD. If that's true, then this segment is in a ratio to GD, it's in a ratio of 2:1. Okay? That's two different things. Okay, AG is equal to 2/3 of the whole thing. If that's true, then AG to GD is 2:1, right? That makes sense? So if I gave you AG was 10, what would GD be? 5. Okay? Don't make that hard. If I gave you the whole thing, let's say I gave you AD was like 15. So then AG would be 2/3 of 15. And what's of mean in math? Times. So it'd be 2/3, like if I did that, it would be 2/3 times 15. And you can reduce that. Right? So if the whole thing was 15, if AD was 15, then AG would be 10. Okay, and the other side would be 5. GD would be 5. Okay? Okay, and same thing on the other ones. If I said BE, now you have to look at your picture. You have to be able to see this BG is the longer one, right? So BG is 2/3 of the whole thing. Okay? And BG is in a ratio to GE 2:1. Okay? Okay, now go ahead and finish writing. Okay? Are you down to there? Okay. And CG would equal 2/3 of CF, the whole thing. Okay? Now, we've already talked about it, but the parts of the median, okay, are in a ratio of 2:1. The longer part is 2/3 of the whole thing. Okay. So the centroid theorem says the medians of a triangle intersect at a point called the centroid. That is 2/3 of the distance from each vertex to the midpoint of the opposite side. But I think both those are critical. Do they give you the whole thing and they want to find the bigger part or bigger segment? Then it's 2/3 of that. Okay? Okay, so draw another triangle. And again, this is they tell you that it's a centroid. Okay? It says in triangle A, and they're labeling this is A, this is B, this is C. In triangle ABC, G is the centroid of the medians. If that's true, okay, and it says AG is 16, find AD. Okay? So AG is 2/3 of AD. We want the whole thing. They're giving us AG. Okay, so substitute in. 16 equals 2/3 of AD. And I want to solve for AD. How do I get rid of that fraction? What can I multiply by? I could divide by 2/3 or multiply by reciprocal. Multiply by the reciprocal on both sides, right? Can't I do that? Multiply by 3/2. Multiply by 3/2. These would reduce. Those would all divide out. They reduce or they divide out. Don't say they cancel because that's subtraction. Okay, now reduce. 2 would divide into 2 once. 2 would divide into 16, 8. Then multiply 3 times 8 is 24. So what we solved for was the whole thing. Now, if that's true, what's GD? 8. Does it check that these are in a ratio of 2 to 1? Yeah. Okay.
So can you just find like GD and add them up instead of fraction?
Sure. Yeah, you could go the other way. You could say take half of that and then add it. Yeah. Yep. Okay, everybody, I'm going too fast. Is that enough time? Yeah, what he's saying is you could take the larger one, and if they gave you the smaller one, you'd double it. Yeah, if they gave you the larger segment, divide by 2, and then add these two together to find the whole thing. Yeah, there's more than one way to outfox that. Okay. Okay, so we just went through the third center of a triangle, the centroid. It's the intersection of the medians. Okay? Okay. And I can come back to this at the end. Okay? Okay, the next one is an altitude. Definition of an altitude. Okay? You should have worked with altitudes a little bit, probably in 6th, 7th grade math, 8th grade math when you were doing base times height. Like in an area of a triangle, base times height divided by 2, or 1/2 base times height. Usually they gave it to you though. They gave you the altitude. Okay? The altitude of a triangle. Altitude of a triangle is a segment perpendicular. Just use the symbol for perpendicular. Altitude of a triangle is a segment perpendicular to the side of a triangle that has a vertex as one endpoint. Okay, so it's got the vertex as one endpoint and a point on the line containing the side opposite the vertex as the other endpoint. So it's just going to go from the vertex perpendicular to the other side. What's the difference between an altitude and a perpendicular bisector? Perpendicular bisector still had a right angle down here, didn't it? But it actually bisected this side. It would have been, perpendicular bisector would have been about over here. Okay? This one goes from the vertex perpendicular to the other side. That's an altitude. So this line would be an altitude. Go from the vertex A perpendicular to the other side. So notice it's not dividing these into congruent segments. Okay? So the altitude of a triangle is a segment perpendicular to the side of a triangle that has a vertex as one endpoint and a point on the line containing the opposite on the side opposite the vertex as the other endpoint. So it just basically goes to a point on the other side, and it does create, they're marking it on the outside of the, but it does create, this line creates a perpendicular, so this whole thing is a right angle inside there. This, if you wanted to mark, it's actually from here, that's a right angle. This would also be a right angle. Okay? The point where those intersect is called the orthocenter. Okay? The orthocenter is the intersection point of the altitudes. Okay, then I want you to look in your books on page 339. Okay, go to page 339. Okay, on your iPads or your books, go to page 339. You have all four centers now of the triangles. You've got the circumcenter, the incenter, the centroid, and the orthocenter. Okay, you have them in both sets of notes, but the good thing in your book, on page 339, the author has put them all together in a table. Okay, if you look at that table up at the top of page 339, the circumcenter, okay, it's the intersection of the perpendicular bisectors. The part that I think is most helpful is the triangle out at the right, where they've marked what's congruent, which part is congruent. Okay, on the second row, the angle bisectors. If you take all the angle bisectors and intersect them, that's the incenter. Okay, and look at the picture out at the right. If you take what we did today, the medians, okay, if you take all the medians and intersect them, you get the centroid. Okay, and then on the last one, the last row, the altitude. Okay, you could actually mark on the medians. Okay, if you go back on the medians, go back up here a minute on the medians. It made those opposite sides segments congruent. Look on that picture on page 339. Now you guys can't mark it on your iPad, but they should have had little red marks marking like AD congruent to CD. Okay, so they do on the left side, but not on the triangle. Okay. Okay, that should finish up your notes. Okay. The assignment for Monday is up there on the board. Okay. Okay. Does anybody need any part of this left up here?